Assalamu alaikum, guys. What's up? Okay, so I'm going to be very much clearly audible. Now, listen to me very carefully, guys. I'm going to be solving. I can just let me just go through the settings and let's see. Okay, everything seems to be just fine. So let's just begin solving. This is going to be part two of that worksheet that we were doing, and this is for AS. And we are going to be focusing. We are still going to be focusing on questions dealing with momentum or kinematics and the dynamics part, right? So we are going to be solving some questions. Okay. Listen to me very carefully. These questions are very important because I'm predicting that you are going to come across questions like these in the 2023 examination. So let's just begin. A ball of mass 0.030 kg moves along a curved track as shown in figure 2.1. You can clearly see this track, right? So let's see. The speed of the ball is 1.3 meter per second when it is at a point A at a height of this. The ball moves down the track and collides with the vertical wall at point B. Okay, so we have a collision over here, but just be careful. There is an initial speed over here, so that means it initially has kinetic energy. The ball then rebounds back up the track. It may be assumed that the frictional forces are negligible. Okay, so let's see. First of all, we need to calculate the change in the gravitational potential energy of the ball and moving from point A to point B. So let's just find it out. So first of all, change in GPE must be equal to mg delta h, which means the change in height. So the mass itself is 0.030 multiplied by 9.81 multiplied by the height difference is actually 0.31. So that means this value is going to come as, let me just find my calculator. Without calculator, the calculations are going to be slightly complicated. Ah, okay. So let's see, 0.30 multiplied by 9.81 multiplied by 0.31. And this gives me a value of 0.91. 0.91. Oh, wait a minute. 0.030 multiplied by 9.81 multiplied by 0.31. And this gives me a value of 0.091. 091 joules. So 0.091 joules. Okay. Um, okay. So that does it. Let's move on to the next question. Show that the ball hits the wall with a speed of this. Okay. So that means we initially had kinetic energy, and we can see that initially there is going to be some potential energy as well as kinetic energy, so we can convert, and since the frictional forces are negligible, that means at the end all these energies would convert to kinetic energy. So we are just going to be writing this down. So first of all, let's just zoom out a bit so that I can copy these values over here, which means initially we had initially this is going to be the initially. So mgh plus ke must be equal to ke final at B. So therefore mgh would be 0.091. Wait a minute, there is something that I can still do. We can get rid of m overall. So this would be mgh is equal to half mv square plus sorry, equal to, this is actually plus, and this is actually equal to half m v final squared. So we can see that we can get rid of m completely. We don't need m. So let's see. So gh would be 9.81 into the height is actually 0.31. Wait a minute. Yep, 0.31. So plus half times the initial speed, which is 1.3 squared. This is equal to 1/2 into v final squared. So let's just pull this calculation off and let's see what happens. So this is going to be 9.81 multiplied by 0.31 plus 1.1 divided by 2 multiplied by 1.3 squared, and then divided by, divided by 0.5. And this gives me a value whatever, and then we are going to be applying the root operation, and this gives me a value of VP as VF, this is actually FV final. So V final is actually 2.8 meter per second. So this is done. Okay, that was simple. Let's move on to the next part. So let's just scroll down. Okay. The change in momentum of the ball due to the collision with the wall is actually this. This is the change that is given to us. The ball is in contact with the wall for a time of 20 milliseconds. Determine for the ball colliding with the wall the speed immediately after the collision. We need to find the speed immediately after the collision. So let's see. We have the change in momentum of the ball due to the collision is this. So that means we can work this out this way. The change has to be negative if we are going to be considering that it is acting on the ball and the ball is moving towards the left. So I'm just going to be writing this down as 0.096. This is the value, the change. And so the change would be equal to V final. This is going to be final. So 0.030 multiplied by, I forgot the initial speed. The final speed is something that we need to find out. So this final speed is going to be towards the left side. So this is going to be negative again. And let this be V. And we have a plus sign over here. But then again, this has to be, because this is a change in momentum, so we will have a negative sign over here. This is going to be subtraction. And then the thing is, initially the ball was moving towards the right, so this is going to be plus. So plus brackets, this would be, let's just keep it as negative over here, and this automatically becomes negative. So 0.030 multiplied by the final speed is actually 2.8 towards the left side. So that makes it minus minus. And so let's just pull this calculation up and let's see what happens. 0.096 plus 0.030 multiplied by 2.8 divided by brackets minus 0.0 minus 0.030, and this gives me a value of 0.4. So I'm getting a value of 0.4 meter per second. Okay, so that does it. That makes sense. Next step, the magnitude of the average force on the ball. So force is equal to change in momentum over the change in time. So the force change in momentum is actually on the ball, so that is going to be towards the left hand side. So minus, oh, they are just concerned with the magnitude, so let's just cancel out the minus sign. So 0.096 divided by 20 milliseconds, so that is going to be 20 into 10 raised to power minus 3, and that should give me a value of 0.096 divided by brackets 20 into 10 raised to power minus 3, bracket closed. And this gives me a value of force of 4.8 Newton. Let me just find it out again. 0.096 divided by 20 minus 3. Oh my God. 0.0 divided by 20 into 10 raised to power minus 3. Mind you, when I'm dividing, I always keep everything in the brackets. So this is actually 4.8 Newton. So this is correct. Okay. Next part. State and explain whether the collision is elastic or inelastic. Well, we have to state it. You can clearly see that after the collision, the speed became less. Initially, the speed was more. This happened after the collision. Okay. So that means we can use the concept of law of restitution. We can use that. And that means the relative speed of approach is not equal to the relative speed of separation. So I'm just going to be writing this down. Not equal to so this is bound to be inelastic. We could have proven it using the kinetic energy before collision and kinetic energy after collision. We could have used that as well. But then again, I find that the law of restitution is much more powerful and much faster. Anyways, in practice, frictional forces are significant so that the actual increase in kinetic energy of the ball in moving from A to B is 76 millijoules. Okay. So the length of the track between A and B is actually 0.60. Use your answer to determine the average frictional force acting on the ball as it moves from A to B. Okay. So let's see. The thing is, we have to use A. But then again, I prefer answering this question slightly differently because I will go over the entire step over here. Let's see. We initially had kinetic energy as well as the GP. We had the gravitational potential energy as well as kinetic energy. यानी ये energy तो शुरू में थी. उसके बाद when it reached B, what happened was that the gain in kinetic energy was actually less. So we can work this out. We can definitely work this out. This is how we are going to be doing it. So initially, I want to find the loss in energy. Initially, total energy must be equal to 0.090091, I guess. That was the GPE plus half times the mass 0.030 multiplied by the initial speed was actually 1.3. So 1.3 whole square. Okay. So this is the total energy initially. And what happened was that after that, something happened. This energy was the total initial energy. But afterwards, after, oh my God, at point B, in fact, initial total energy at A, at point B, we have something else. We have the initial kinetic energy half 0.030 multiplied by 1.3 whole square plus this energy. We have some gain in kinetic energy, which is actually 76 millijoules. So the total kinetic energy at the end is actually 76 millijoules. So 76 into 10 raised to power minus 3. This is how we proceed. This is at point B. So finally, loss in energy is equal to work done against frictional forces. So that is going to be equal to, we have to subtract the two energies. So let's see, 0.091 plus 0.5 multiplied by 0.030 multiplied by 1.3 whole square. So this gives me a value of whatever I'm getting, and then let's just write it down, 0.11635 joules minus 0.5 0.5 multiplied by 0.030 multiplied by 1.3 whole square plus 76 into 10 raised to power minus 3. And this gives me a value of 0.10135. So let's just calculate this value and let's just subtract the two values and let's see where we stand. So 0.11635 gives me a value of 0.015, which is equal to force into distance. So 0.015, and the distance is actually 0.6. So divided by 0.6 gives me a value of frictional force is coming as 0.025 Newton. This is how you do it. Let me just verify it again. All the values 0.091 plus 0.5 multiplied by 0.3030 multiplied by 1.3 whole square, and then subtracting the value, which is actually 0.5 multiplied by 0.030. I hope it was actually 0.03. Okay. Let me just verify it again, just in case. What was the mass of the ball? Yeah, it is right. So let's see. Subtracting it by 1.3 whole square and then simply adding 76 into 10 raised to power minus 3. Yep, all calculations are correct. There is a faster way to do it. There is definitely a faster way to do it. The thing is, you should have realized by now, I took a lengthy step. I went all the way. मैंने शुरू में total energy निकाली और फिर मैंने final energy निकाल कर जो final useful energy थी उन दोनों को subtract किया. There is a much faster way. You can clearly see that over here, that this energy is being repeated on both sides. Can you see that? This is being repeated. So that means at the end of the day, we were actually subtracting these two values when we were finding the work done against friction. So if we were subtracting these two values, that means you never had to consider the initial kinetic energy. It was already cancelled out. You could have simply done it this way कि ये वाली जो हमारे पास शुरू में जो GPE की वैल्यू थी, इसी में से ही डायरेक्टली यूजफुल काइनेटिक एनर्जी सिर्फ ये वाली माइनस कर लेते और डायरेक्टली फोर्स इनटू डिस्टेंस से कर लेते, you would still have gotten the same answer. That is one way to do it. But then again, at least I just considered everything, the picture that was given to me, and this can actually happen in the examination. But if you follow the rules, you will always get the right answer. Remember it. Anyways, let's move on to the next step. Next question. Define velocity. It is actually the rate of change of displacement. Okay. Then a ball of mass 0.45 kg leaves the edge of a table with a horizontal velocity v as shown in figure 2.1. So that means, first of all, let's see, air resistance is considered negligible. We can see that this horizontal component will remain the same throughout. It will not change at all. If it is not changing, so that means v would remain the same. But the initial vertical velocity would definitely be 0. So let's see, calculate for the ball the horizontal velocity v as it leaves the table. We need to find this v, the horizontal component. But the information that is given to us is insufficient at this point in time. The reason is that we need the time taken for the ball to actually move from this position to this position, the horizontal movement. So for that, we need the time, and we can find the time using the vertical motion. So initially we are going to be dealing with the vertical motion. So vertically we are going to be dealing with this. Oh my God, vertically, initial speed is going to be 0. The final speed, be careful, I'm going to be using V, but that is going to be Vy then. Vy, we don't need that. The displacement vertically is actually 1.25 meters. Acceleration due to gravity is going to be, I'm going to be taking it as positive because we know when something is falling down, the vertical component will tend to increase. So this is going to be 9.81 meter per second squared. And finally, we can find T. So T is going to be the question mark. So S is equal to UT plus half AT square. So UT would become 0. So 1.25 is equal to half into 9.81 multiplied by T square. So this is going to be T squared. And let's just find it out. So 1.25 multiplied by 2 divided by 9.81. And then root operation gives me a time of 0.505. So the time is actually 0.51. Let's just take it as बल्कि 0.0505 ले लेते हैं इसको time को. ठीक है, this is the time. So now we can find the horizontal component, and for that V would be equal to the distance over time. So the distance is actually horizontal distance is actually given to us as 1.5. So 1.50 divided by this time 0.505 would give us, let's see, 1.5 divided by answer. Oh my God. 1.5 divided by answer. Oh my God. Divided by 0.505 gives me a value of 2.97. So I'm just going to be rounding it off to, let's say, one significant figure. So this is going to become 3.0 meter per second. So I got this answer. Okay. Next step. The velocity just as it hits the floor. Now, this is a very smart question. You need to find the velocity as it hits the floor. And there are apparently two components that you need to deal with. One of the component, we already have that, and that is in the horizontal direction. This value is already with us, which is actually 3 meter per second. But additionally, we need to find this component as well, the vertical component as it collides, as it collides with the floor. So when we have this component, we can use Pythagoras theorem to actually find the final velocity. So let's just do it. So velocity just as it hits the floor. So initially we are going to be working again in the vertical direction. Vertically, we would have v square is equal to u square plus 2s. So final velocity vertically, let's just keep it as y, is equal to square plus 2 times acceleration 9.81, and the vertical distance is actually 1.25. So let's see, 2 into 9.81 multiplied by 1.25, and let's apply the root operation. Under root, answer gives me a value of Vy as 4.95 meter per second. So at the end of the day, this is actually 3 meter per second. And the vertical component is actually 4.95 meter per second. We can easily find the resultant velocity as it just hits the floor, and that is going to be this value. So using Pythagoras theorem, final velocity must be equal to root operation 3 square plus 4.95 square. So let's see, squaring the answer plus 3 square and applying the root operation gives me a value of 5.79, so 5.8 meter per second. So that does it. Let's see. the angle to the horizontal. For the angle to the horizontal, we need to find this angle. So we can easily use tan. Let this be theta. So tan theta should be equal to the vertical component, which is actually 4.95 divided by 3. So make sure your calculator is in degree mode. So tan inverse is going to be 4.95 divided by 3, bracket closed, and let's see. 58.7. So this is going to be, I'm rounding it off to 59. Just do it again. Tan inverse 4.95 divided by 3, bracket closed. This gives me a value of 58.78. So let's just round it off to 59. Okay, so this is also done. The kinetic energy just as it hits the floor. So we already have the final speed. This is the final speed. So half into, let's look at the mass that is given to us in the question, which is 0.45, which is actually 0.45. So 0.45 multiplied by 5.8 whole square. So this should give us a value of 0.5 multiplied by 0.45 multiplied by 5.8 whole square. And the kinetic energy that I'm getting is 7.569. So 7.6 joules. Finally, the loss in gravitational potential energy as it falls from the table to the floor. So the loss in GPE is change in GPE, which is actually equal to mg delta H. So the mass is actually 0.45 multiplied by 9.81 multiplied by the height. It fell from, which is 1.25, which is 1.25. And finally, 0.45 multiplied by, oh my God, 0.45 multiplied by 9.81 multiplied by 1.25 gives me a value of 5.5. The loss is actually 5.5. Okay, joules. Now there is a problem. This is not a problem, it's a fact. The loss in potential energy is actually less than the kinetic energy. Normally, it happens that the loss in GPE is actually greater than the kinetic energy. But then you guys are not realizing this fact that there is a horizontal component of velocity which is actually contributing to the final kinetic energy. So explain why the kinetic energy of the ball does not equal the loss of this. So horizontal component of velocity is contributing kinetic energy is contributing so Ke more than loss of GPE. I guess that's it for today, guys. So I've done some more questions for you. And in the next session, we are going to be moving on to some other topic as well. I hope this is clear. Thank you, guys. Allah Hafiz, apna bahut bahut khayal rakho. So that's it.